Yesterday we talked about segment angles that are formed by chords. Today we're going to talk about the segment measurements that are formed by chords. Very good idea to have that formula sheet ready and close to yourself as we work through these. These will be the first examples that you will see on your Delta Math. So let's just jump right in. So this is the first example we see. It says, given the circle below chord JK and LM, find the length of MN and then round to the nearest tenths of a number. So here's the formula that we have on this. Anytime we have the segments that are crossing inside, these are chords that intersect inside of the formula we're going to use. We have to look at these independent line segments, and we're going to set up an equation. And our equation is going to be the two parts on the same line. In this case, we need to label this actually. This is going to be x. The two parts on the same line, in this case 32 and x, are multiplied together. The product of this number is equal to the product of the other segment, and that would be 21 times 24. So once we have these values, we just simply solve for x. (24) times 21 is 504. We divide both sides by 32. And the segment that we see equals 15.8. And we did a little rounding there, so we're going to change this sign to an approximation. It actually came out to 15.75, but it would round up because we are rounding to the nearest tenths. These examples work pretty quickly, so we're going to just try to get a couple of these in each of these, each example for one of these. So we are looking for side JN here, our segment JN. So again, we set it up the same way. 19 and 20 are shared on the same line, so the product of those numbers will be equal to the product of these two numbers. So 37 times x will be equal to the product of 21 times 19. 21 times 19 is 399. 37x equals that. We divide both sides by 37, and again we're rounding to the nearest tenths again. So we learn that x is approximately 10.78. So that would be a value that rounds up, so it's approximately 10.8. Right, this example is probably going to be the formula that's most confusing, so make sure you take a look at this with us. So when we're doing these, we have two secant lines that intersect outside of the circle. So what our formula is for this one is the outer segment, that means outside of the circle, times the entire segment, the whole thing, will be equal to the secant line, the outer times the whole thing again. These two segments, if we use this formula, will create the equation for us. So what we're looking for here is side PQ, which is this. So again, this is where it's kind of an interesting formula. We are looking for the outer segment in the, we'll use this line to start here, PR. The outer segment, that's the segment outside of the circle, is 44. Times the entire segment, the whole segment. So the whole segment is the 44 plus the x value that we see on the inside. So that is our whole segment. Now the other one, the other line, secant line, is the outer segment. In this case, that's 40, is equal to the entire segment. We're going to write this out for today, for right now, but you can do this work either in your head or on a calculator. So the entire segment would be 40 plus 31. We'll zoom in and take a better look at this equation here. All right, so here's what we're going to do. We can distribute or we can divide the 44, but let's take a look and see what happens on the right side of the equation. So this is 40 times 71 equals 44 times 44 plus x. Now, if I could divide that 44 out of the number on the right side in a simple fashion, I probably would do that without distributing. So I'm going to go ahead and multiply this. This is 40 times 71, which is 2,840. Now, here's where I'm going to decide whether I'm going to distribute this 44 or if I'm going to just divide this 44. And the way I'm going to decide this is I'm taking 2840 and I'm dividing by 44. It gives me a weird decimal value here. I guess it really doesn't matter when I do it. So let's practice doing this because a lot of times this is easier for us to do. So what we have here is 44 times 44 plus x. So instead of distributing in this 44, we have the option of just simply dividing it away from both sides, just like you see us doing here. So 2840 divided by 44 is 64.545, so that would round up to 55, equals, now our parentheses is gone, 44 plus x. And this keeps me from having to divide by much larger numbers here and distribute and work with larger numbers. I suggest you start thinking about doing this when you can. And then the last step, of course, is to subtract the 44. I should have an approximation sign here, actually. So what we end up with is x is approximately 64.5 divided by 44 is 20.5. Now this is interesting. Take a look at this. My rounding, I almost made a mistake here. It says round to the nearest tens. Well, this 5 is not a true 5. It was a rounded 5. It was 4, 5. So this actually does not round up to a 6. It stays 20.5. Should have probably read those instructions on the rounding before I started doing that. Just be careful of that. Remember, 5s are technically kind of neutral numbers, but rounded up 5s do not round up again. Only true 5s round up. All right, here's our next example. This one really is, if you think about it, the same formula. It's not going to feel like it, but it actually is. So just like on the last one, we had to multiply the outer times the whole. And we have to set that equal to the outer times the whole. So instead of trying to memorize two formulas, here's the way I look at this. Let's take a look first of all. We don't know what ji is, so we're going to label it x. So let's take care of this side right here because it's just like the last one. The outer segment is 16. The whole segment is 16 plus 8. And again, I encourage you to do that work in your head. equals the outer segment. Well, the outer segment is x, but the outer segment is also the whole segment. The whole thing is on the outside. So really, if you think about it, the formula is the same. It ends up being x times x, which is x squared. Most formulas are going to tell you, when you look at these, that the formula is not outer times whole. What it is outer squared. But I prefer to look at it as, well, the outer segment, the whole thing is on the outside, so therefore it is x times itself. So here we go. 16 plus 8 is 24. X times x is x squared. 16 times 24 is 384 equals x squared. And we take the square root of both sides. Now, like I said, I want to kind of prepare you for Algebra 2 as well. The square root of 384 is actually 19.6 and negative 19.6. But we don't have a negative line segment, so we reject the negative solution and we accept only the 19.6. That's your fourth example from your Delta Math assignment. All right, now for the level 2 type things. On the level 2, what we're going to see is just more variables. So let's go ahead and label what we have. It says given the circle, we have secant lines. We now learn that XV is this entire segment that we see over here. Let's go ahead and label that. XV has a measure of 15. That's the whole segment, by the way, when we start looking at our formula. And it says XW has a measurement of 10. So we know this segment here is 5. It really doesn't serve any purpose for us, but we know that it is 5. And then the other thing we know is that UV is 6 and TU is unknown. So we're going to use the same formula here, except for this one we're just kind of going to have to build off of our information. They didn't actually tell us that this segment was 5 units long. We had to deduce that. So technically it's a little harder work, but not much. So let's go ahead. Remember, it's outer times whole equals outer times whole on the other segment. That's the formula we plan on using here. Well, the outer segment on the XY line is 5, and the whole segment is 15. On the other side, the outer segment is 6, and the whole segment is x plus 6. So I personally like to come in here and see what my left side is going to be. 5 times 15 is 75. So at this point, we end up with 6 times x plus 6. I really, instead of distributing, I would much rather just divide by 6 right here. The disadvantage of doing it on this particular question is we're about to have a rounded number, and we're dealing with a rounded number a little sooner than we really need to. But this rounded number is actually a pretty friendly one. 75 divided by 6 is 12.5. On the right side, the 6's cancel, and I'm left with x minus 6, plus 6, excuse me. So the only thing I need to do to get the x by itself now is to divide by 6. If you distributed this value, you're going to do the same steps that I just did. You're welcome to try it on your own. you're just going to be dealing with bigger numbers as you go. By the way, this one, notice I do not have an approximation sign because it was not a rounded number. It was 12.5. So we know that this one is exactly 6.5. All right, last example. So let's take a look at this and let's label what we have. It tells us we have a tangent line LM, we have a secant line ONM, and it tells us that NM, that's from here to here, is 3. And then it tells us OM is 13. That's the whole segment, by the way. Of course, this one would be 10. And then it tells us the other side is unknown, so we're trying to solve for x. So this one's just like the other one. It's just different values. The formula is still the same. We multiply the outer segment times the whole segment. 3 times 13. And on the other side, we are going to essentially do the same thing. The outer segment times the whole segment. Well, that's both the same thing. So it ends up being x times x. 13 times 3 is 39. X times x is x squared. We then have to square root to get rid of the squared. And the square root of 39, this one is an approximation, so we're going to have to put our sign here, is approximately 6.244, a value that does not round up. So it would just be 6.2. All right, there you have those. You're going to have a few examples of your own for Delta Math. Just make sure you're using the right formula and make sure you round well. Some of you, that's been your biggest issue. Good luck.